In this video, we're going to present ways to define your own functions. And for that purpose, we have this worksheet. I selected functions related to probability just because I used to teach this class. And so I'm going to do, for example, the definition of what's called the probability mass function, PMF, for the binomial distribution. And let me show you how to type it here. You type f of x space bar equal n, and then use the exclamation point, which is the factorial, divided by x factorial times, that will create the parenthesis there, and then n minus x space bar factorial, space bar several times until you get to multiply a certain probability raised to the x, space bar times the probability of the complement 1 minus p raised to the n minus x, and click somewhere. What I did here was just select this and change the color of the text to blue, and that's how you get to blue. The rest of that is just text indicating that this function is valid for integer numbers from 0 to n being the number of repetitions of a certain experiment. I'm going to delete this then. So I'm defining a function here called f of x, which represents the probability mass function of the binomial distribution. And then I'm defining what is called the cumulative distribution function, which is the sum from k equals 0 to x of the function f of k. Remember, since x acts as text value and integer values, k, typically used for integers, is a valid selection here. So with this definition and this definition, I have two functions, and I'm going to apply now to a particular value, n equal 10, p equal 0.30. And so just calling a particular value like f of 6, for example, equal will give me the particular probability. Or if I use uppercase f of 6, it will give me the cumulative distribution. Certain ideas are used to calculate probabilities. For example, the probability that a certain random variable is within 3 and 6 will be the summation of the probability mass function from 3 to 6, or equal to the cumulative distribution at the upper limit 6 minus the cumulative distribution at one value below the lower limit. You can check that. We're going to do here the summation. I'm going to lift this a little bit higher. The summation of f of k, and k equal, let's see, 3 to 6. And then I'm going to do here the upper limit of 6 minus 1 below the lower limit, and give me this exactly the same results. Just demonstrating that. Plot. Here's what you need to type. If you type xx colon range 1n, you get a vector of values from 1 to n. Actually, we should have started at 0, but that's okay. If I change, see, we're going to change this to 0, so I'm going to increase space in here and change this from 0 and change this from 0 to n, and then get the corresponding probability mass functions by vectorizing f of x. X is just the values of x. And then this is a presentation of the values of x and the probabilities. And then to produce this plot, there's going to be a video about plots later on, but just give you a preview. You go to Insert, Plot 2D, and drag it over here. And then the matrix that we prepared is matrix M that augments XX with FF. We type it right here. And so it gives me something in there, right? What I'm going to do is just going to click in here and drag this down to here. And then as I click on the graph and hold the Shift key, I'm going to move my mouse wheel. This only works with the mouse wheel, regrettably. To expand the X, or if you prefer to contract the X, from 0 to about 10 as I have it right there. Okay. Now the vertical scale, click in here, hold the Control key, move the mouse wheel upwards until you start seeing that graph going up. Because this is a large file, it's taking some time to do it, so I'm going to pause and show you the final result. So this is what you get. I'm going to modify it slightly. Okay. And so what you have here is a continuous function where the individual points are connected by lines. If you want to change that, you can go to the plot panel and click on this, and then the lines are converted to points. To produce the cumulative distribution function, we do a vectorizing of the uppercase f of xx and produce a new matrix called mm. And this matrix mm, when it's displayed together and modified together with the other one, we'll get this. I'm going to show you right here. I'm going to select this, do Control C to copy, and Control V to paste. All right, so here I have this. I'm going to select this, and then I'm going to go right here and type mm in there. And you can see there's a red point in there, but the others are higher. And so you need to go from 0 to 1 right here. And so click on the graph, hold the Control, and move the wheel down, and then you get the result with the probability mass function in blue down here and the probability cumulative distribution function in red. And that's the idea behind this particular example. I actually have another example here is in the exponential function, which is a continuous function. And for that, since I've used lambda somewhere before, I use the function clear lambda, and it means that the value of lambda gets erased, and I can use it to define my what is called a probability density function for continuous random variables. Lambda e to the minus lambda times x, and you can evaluate the function, and then it turns out that the cumulative distribution function is an integral, and that can be evaluated as an uppercase. You can prove these. For example, for the value of lambda that I have defined here is 4.5, and so you could write the integral of f of psi. So put x Control G, space bar, comma x Control G, space bar 0.2, comma 1.2. I'm going to drag this over here. I'm actually going to do this. Move this to the left. So that's that integral, right? And then the other value I'm trying to calculate is f of 1.2 minus f of 0.2. For continuous distribution, this is the way that it's defined. And as you can see, you get exactly the same result for those functions. Plots of the function are presented here. And that's another example of the functions that are defined by the user. I have a couple of more examples in there, but I'm going to provide them in the following video. And so for the time being, we're going to stop this video right here.